Soil genesis deals with the factors and processes of soil formation. Soil forming factors are classified into 5 categories, namely climate, organisms, parent material, slope or topographic position, and time. In this chapter, we are discussing about the important processes of soil formation through various mechanisms. Soil forming processes are classified into 4 types, namely addition, loss, transformation, and translocation. These terms can be easily remembered by the mnemonic sentence, the soil formation is a mathematical process. In mathematics, the basic processes are addition, subtraction, multiplication, and division. In pedogenesis, they can be roughly related to these processes as addition is addition, subtraction is deletion or loss, multiplication is transformation, and division is translocation. If you are a student of biology, you can also remember these processes by mnemonic formula as the soil formation is a mutation process. You have studied that the chromosomal mutation is nothing but addition, deletion, transformation or inversion, and translocation. Soil forming processes. The basic processes involved in soil formation includes the following: addition, loss, transformation, and translocation. Additions. Additions are the materials added to the soil such as organic matter and decomposing materials or new mineral materials deposited by the forces of ice, water or wind over time. This happens in the top layer of the soil. In poorly drained soils, the organic materials accumulate since waterlogging prevents it from being oxidized or broken down by soil organisms. In well-drained soils, the materials accumulate when they are held up by the root systems. Depositions by the forces of wind, water or ice equally contribute to the accumulation of new materials. Some plants, with the help of bacteria, fix atmospheric nitrogen and ammonia compounds into the soil as nitrates. Loss. Losses through the movement of wind or water or uptake by plants. Soil particles like sand, silt, clay and organic matter or chemical compounds can be eroded, leached or harvested from the soil, altering the chemical and physical makeup of the soil. The main mechanism of losses is by leaching. Transformation. Transformations are the changing of one form of soil to others, like the chemical weathering of sand and formation of clay minerals. The main mechanism of transformation is through humification and eluviation. Translocation. Translocation means movement of soil constituents, organic or mineral, within the profile or between horizons. Over time, this process is one of the more visibly noticeable as alterations in color, texture, structure become apparent. Mechanisms of soil forming processes. The mechanism of soil formation can be classified as leaching, humification, eluviation, podzolization, calcification, decalcification, laterization, salinization, desalinization, alkalinization, dealkalization, pedoturbation, and glaciation. Leaching. Leaching is the removal of soluble components of the soil column. As water washes down through the soil, it can carry away bases such as calcium held as exchangeable ions in clay humus complexes, as well as acidification through the substitution of hydrogen ions through the movement of water, wind, ice, or the uptake of the accumulated materials by plants. The new particles including clay, organic matter, silt, or other chemical compounds are leached and eroded away or taken up from the soil by plants. As a result, the physical and chemical compositions of the new accumulated materials together with the soil parent material are altered. A prime example of leaching out of some carbonates, magnesium and other minerals. Humification. Humification is the process of transformation of raw organic matter into humus. It is extremely complex process involving various organisms. First, simple compounds such as sugars and starches are attacked, followed by proteins and cellulose, and finally very resistant compounds such as tannins are decomposed and the dark colored substance known as humus is formed. 3. Illuviation. Illuviation is the accumulation of dissolved or suspended soil materials in one area or layer as a result of leaching or percolation from another. Here, the soil particles held in the suspension after the leaching, such as clay, are transformed, after which they accumulate. Transformation is the chemical weathering of silt, sand, and the formation of clay minerals, as well as the change of organic materials into decay resistant organic matter. After the clay and other accumulated materials are washed from upper horizons and deposited in the lower horizons, the plants and animals are also responsible for transformation of the soil by physically and chemically breaking down the materials. The soil begins to take shape on its own through transformation, which improves natural drainage and nutrient composition. The horizons formed by this process are termed as alluvial horizons. B horizon, especially BT, the process leads to textural contrast between E and BT horizons and higher fine total clay ratio in the BT horizon. Alluviation. Alluviation means washing out. It is the mobilization and translocation of certain constituents like clay, humus, Fe2O3, Al2O3, SiO2, CaCO3, other salts, etc. from one point of soil body to another. It is the process of removal of constituents in suspension or solution by percolating water from the upper to lower layers. The alluviation encompasses mobilization and translocation of mobile constituents resulting in the textural differences. The horizon formed by the process of alluviation is termed as alluvial horizon, horizon E. Translocation depends upon relative mobility of the elements and depth of percolation. Podzolization. Podzolization encompasses the downward migration of metals like aluminium and iron together with organic matter from the surface areas and their accumulation in the profile's deep areas. This process is characterized by a strong acidity that causes the slow development of organic matter, which releases abundant organic compounds with an acidic nature, and an extreme alteration of mineral phase, releasing abundant elements that are lixiviated by the drainage waters. The medium is enriched with insoluble elements such as iron and aluminium, which are migrated downward by the organic compounds towards deeper horizons. In short, an alluvial horizon is formed on the surface with intense substance loss. The organometallic complexes migrate to the subsurface horizons and they accumulate in B horizon, creating BH and BS horizons. The noticeable horizon consequence is O, A, E, BH, BS. BH horizon contains more than 1% organic carbon, less than 0.3% pyrophosphate, extractable iron, and has a ratio of organic carbon to pyrophosphate extractable iron of 20 or more. Generally, the color value and chroma are 3 or less when moist. BS horizon is characterized by sesquioxides of aluminium and iron. The process of podzolization operates under favorable combination of the following environments. Climate. A cold and humid climate is most favorable for podzolization. Parent material. Siliceous or sandy material having poor reserves of weatherable minerals favor podzolization as it helps in easy percolation of water. Vegetation. Acid producing vegetation such as coniferous pines helps in podzolization. Through this process, the overlying alluvial horizons are getting bleached. The complexes are moving to the brown, red or black horizon, which consists of cemented sesquioxides or organic compounds. A sesquioxide is an oxide containing 3 atoms of oxygen with 2 atoms of another element. For example, aluminium oxide Al2O3 is a sesquioxide. The process of podzolization occurs usually under low pH value. The corresponding soil type is called podzol. In Russian language, podzol means ash-like horizon beneath the surface horizon. Pod means under, zola means ash-like. Spodosol and podosol are the synonyms for podzol. Horizonation. It is the process of differentiation of soils in different horizons along the depth of the soil body. The differentiation is due to the fundamental processes humification, alluviation and illuviation. Calcification. Calcification is the process of precipitation and accumulation of calcium carbonate in some part of the profile. The accumulation of calcium carbonate may result in the development of a calcic horizon. Calcium is readily soluble in acid, soil, water and or when carbon dioxide concentration is high in root zone as CO2 plus H2O equals H2CO3. That is, carbon dioxide plus water gives rise to carbonic acid. Carbonic acid plus calcium in the presence of temperature gives rise to calcium bicarbonate, which is soluble. The dissolved carbon dioxide in water reacts with limestone calcium carbonate to form soluble calcium bicarbonate. This soluble compound is then washed away with the rainwater. This form of weathering is called carbonation. Calcium bicarbonate gives rise to carbon dioxide, water and calcium carbonate, which is solid and precipitates. The process of precipitation is called calcification, and the resulting elevated horizon of carbonate is designated as BK or BCA horizon. Decalcification. In the reverse process of calcification, dissolved carbon dioxide in rainwater reacts with limestone, calcium carbonate, to form soluble calcium bicarbonate. This soluble compound is then washed away with the rainwater. This form of weathering is called carbonation. Laterization. The term laterite is derived from the word lattice, meaning brick or tile, and was originally applied to a group of high clay Indian soils found in Malabar hills of Kerala, Tamil Nadu, Karnataka and Maharashtra. It refers specifically to a particular cemented horizon in certain soils which when dried becomes very hard like a brick. Such soils in tropics, when massively impregnated with sesquioxide to the extent of 70 to 80% of the total mass, are called laterite or latosols or oxysols. The soil forming process is called laterization or latosation. Laterization is a process that removes silica instead of sesquioxides from the upper layers and thereby leaving sesquioxides to concentrate in the soil. The process operates under the following conditions. Climate. Unlike podzolization, the process of laterization operates most favorable in warm and humid tropical climate with 2000 to 2500 mm rainfall and continuous high temperature 25 degrees Celsius throughout the year. Natural vegetation. The rainforests of the tropical areas are favorable for the process. Parent material. Basic parent materials having sufficient iron bearing ferromagnesian minerals which on weathering release iron are congenial for the development of laterites. Salinization. Soil salinity is the salt content in the soil. The process of increasing the salt content is known as salinization. Salts occur naturally within soils and water. Salination can be caused by natural processes such as mineral weathering or by the gradual withdrawal of an ocean. It can also come about through artificial processes such as irrigation. These salts include potassium, magnesium, calcium, chloride, sulfate, carbonate, bicarbonate and sodium. The accumulation of sodium is also called sodification. Salts dissolve and move around with water. When the water evaporates, the salts are left behind. Primary salinization involves salt accumulation through natural processes due to a high salt content of the parent material or in groundwater. Secondary salinization is caused by human interventions such as inappropriate irrigation practices, for example, with salt-rich irrigation water or insufficient drainage. Factors leading to excessive accumulation of salts in soil may be natural or anthropogenic. Environmental factors that result in salinization or sodification. Geological events which can increase the concentration of salts in groundwater and consequently in soils. Natural factors which can channel salt-rich groundwater to the surface, near the surface, or to horizons above the groundwater table. Groundwater seepage into areas lying below sea level, that is, microdepressions with little or no drainage. Waters flooding from areas with geological substrates that release large amount of salts. Wind action, which in coastal areas can blow moderate amounts of salts inland. Natural factors influencing the salinity of soils are climate, soil parent material, land cover, vegetation type, and topography. Human induced factors that may lead to salinization or sodification are irrigation with waters rich in salts, raising water table due to human activities, filtration from unlined canals and reservoirs, uneven distribution of irrigation water, poor irrigation practices, improper drainage. Use of fertilizers and other inputs, especially where land under intensive agriculture has low permeability and limited possibilities of leaching. Use of wastewaters rich in salts for irrigation. Salt-rich wastewater disposal on soils. Contamination of soils with salt-rich waters and industrial byproducts. The most influential human-induced factors are land use, farming systems, land management, and land degradation. Inappropriate irrigation practices such as the use of salt-rich irrigation water and insufficient drainage both cause salinization. Salinization and sodification are often associated with irrigated areas where low rainfall, high evapotranspiration rates, or soil textural characteristics impede the washing of salts out of the soil, which subsequently build up in the surface layers. Irrigation with water that has high salt content dramatically worsens the problem. In coastal areas, salinization may be associated with the over exploitation of groundwater caused by the demands of growing urbanization, industry, and agriculture. Over extraction of groundwater can lower the normal water table and lead to the intrusion of sea water. Desalinization. It is the removal by leaching of excess soluble salts from horizons or soil profiles that contained enough soluble salts to impair the plant growth by ponding water and improving the drainage conditions by installing artificial drainage network. Salinization or alkalization. The process involves the accumulation of sodium ions on the exchange complex of clay, resulting in the formation of sodic soils, solanates. All cations in solution are engaged in a reversible reaction with the exchange sites on the clay and organic matter particles. The reaction can be represented as follows: calcium, magnesium, sodium in clay or organic exchange complex matters give rise to ions of calcium, magnesium, sodium, and carbonate ions, which in turn give rise to sodium carbonate, magnesium carbonate, and calcium carbonate. Solidization or dealkalization. The process refers to the removal of sodium ion from the exchange sites. This process involves dispersion of clay. Dispersion occurs when sodium ions become hydrated. Much of the dispersion can be eliminated if calcium ions or magnesium ions are concentrated in the water, which is used to leach the soonest. These calcium and magnesium ion can replace the sodium on exchange complex and the salts of sodium are leached out. Sodium exchange complex plus calcium sulfate gives rise to leachable sodium sulfate and calcium exchange complex. Pedoturbation. Pedoturbation is synonymous with soil mixing and leads to a homogenization of the soil to various degrees. The mechanisms and vectors by which this mixing is accomplished are many. The implications and impacts of pedoturbation affect soil genesis as well as cultural and physical interpretations made from soils. The most common types of pedoturbation are faunal pedoturbation. It is the mixing of soil by animals such as ants, earthworms, moles, rodents and human activities. Activity of bacteria is yet another important cause of perturbation. Field termites are especially important in tropical climate regions. Floral pedoturbation. It is the mixing of soil by plants as in tree tipping that forms pits and mounds. Faunal and floral pedoturbation together are called bioturbation. Argillic pedoturbation. It is the mixing of materials in the soil by the churning process caused by swell shrink clays as observed in deep black cotton soils. Cryoturbation. Cryoturbation is mixing and churning caused by cold temperatures. Soil perturbation, that is not pedoturbation. Precipitation of surface salts also causes localized disruption of soils. Because it does not result in mixing between soil horizons, it is not considered pedoturbation. Glaciation. The term gley is of Russian origin, meaning blue, grey or green clay. The glaciation is a process of soil formation resulting in the development of a gley or gley horizon in the lower part of the soil profile above the parent material due to poor drainage condition or lack of oxygen and where waterlogged conditions prevail. Such soils are called hydrorphic soils. The process is not particularly dependent on climate like high rainfall as in humid regions, but often on drainage conditions. The poor drainage conditions result from lower topographic positions such as depression land where water stands continuously at or close to the surface. Impervious soil parent material, lack of aeration. Under such conditions, iron compounds are reduced to soluble ferrous forms. The reduction of iron is primarily biological and requires both organic matter and microorganisms capable of respiring anaerobically. The solubility of calcium, magnesium, iron and manganese is increased and most of the iron exists as ferrous organocomplexes in solution or as mixed precipitate of ferric and ferrous hydroxides. This is responsible for the production of typical bluish to greyish horizon with mottling of yellow and or reddish brown colors. Summary. A soil is composed primarily of minerals which are produced from parent material that is weathered or broken into small pieces. There are thousands of different soils throughout the world. Weakly developed, moderately developed, and well developed soils through a combination of 5 important factors: parent rocks, climate, living organism, topography, temperature, and water. Different processes or combination of processes operate under varying natural environment. These processes can be classified as additions, losses, translocations, and transformations. In additions, rain adds water, dust adds minerals. As plants die and animals poop, organic matter is added. Humans also add fertilizers. Losses caused by evaporation, nutrient uptake, leaching of nutrients and elements. In translocations, gravity pull water and dissolved materials down. Organic matter can move in any direction due to craters, clay movement, elevated horizon, and transformations happen by decomposition, weathering, iron rusting, reddening or dissolving, graying, clay formation. The mechanisms by which these 4 processes are affected can be classified as leaching, humification, eluviation, podzolization, calcification and decalcification, laterization, salinization, desalinization, alkalization, dealkalization, pedoturbation and glaciation. Thank you.